All right, guys, lesson 18, homework, page 416. First one, we did A and D together there, so 30% decrease, just continuing on with what we talked about. Decrease is subtracted from 100, which is 70, and then you make it a decimal, 0.70 or 0.7 is fine. 2% increase, so 102% written as a decimal. E, adding to 100. So it would be 100.04%. And then a decimal, remember, 1.0004. So it is tricky there. Watch the decimal points. The other one is the exact opposite. I'm going to subtract it from 100, and I get 99.96%. Drop the percent and make it a decimal. 100% increase, 100 plus 100 is 200. Move the decimal 2 spots is just 2. By what factor does the number of people grow in this problem in 1 year? Well, it's talking about millions of people. Keep that in mind. This is in millions. What factor does it grow in 1 year? Well, it tells us right there, 1.021. If D is time in decades, write in the equation expressing this. So number of people equals 870.5, 1.021, and we're going to take whatever we get times 10 decades, because there's 10 years in a decade. Use a model to predict number of people in India in 2015. 2015 from 1990 is 25 years difference, so I simply plug in a 25 there, plug her into Desmos. Again, it is in millions of people. So here's what I got. Your calculator will tell you 1463.6 million. And then I just translated it to get rid of the word million. So what is that? A little less than 1.5 billion. People, 1463, then round accordingly. Let's see, the population was 1.311 million. How does that compare? Well, that is quite a bit less than our prediction. The predicted number is about 150 million larger than our predicted was 150 million bigger than this one. You can see that between those two numbers right there. It doesn't ask exactly what it is, so you could just say that it was less than our prediction. Question 3, select all that works. It is 12%. Written as a decimal is, of course, 0.02, so you do have to add it to the original as well. So 1 plus 0.12, so I'm looking for 1.12. That would be this one here and this one here. This one would be 0.88. That'd be a 12% decrease. Let's see, this would be 1.01. If I simplify that, that's not it either. So just B and C, I believe, for that one. Question number 4. Keyword for this one is monthly. So 18% would need to be divided by 12. So it's down to C or D. And it is monthly for 5 years. So 12 times those 5, so 60 times it will happen, so your answer is D. Explain how the expression would change if the bank had compounded the interest quarterly instead of annually. Well, you would have to take 8.5% or 0.085, and you'd have to divide it by 4 because it is quarterly. And then the exponent would have to be 4 times a year for 3 years. The exponent would have to change to 12. Okay, then it says actually find it. Fine. You just wrote down how it would change. So the interest rate would have to be divided by 4, and our exponent would be 12. Could simplify that if you want. Either way is fine with me. Question number 6. How much money was in the bank when it opened? Well, it tells you right there. It doesn't say that it's in millions or anything, so we're just gonna write $1,000. Sketch a graph. All right, well, we can do years here. 1, 2, 3, 4, 5. Starting at 1,000, so I'm gonna go by 500s. I'm gonna mark the 250s as well. That would be straight cash. So $1,000, put a dot, plug in 1, you get 1070. Plug in 2, you get 1145. And again, you can put that into Desmos and check it, or you plug those numbers in 1, 2, 3, and so on. So there's my sketch. Money's going to gradually increase there. That's good enough for now, I think. Eventually that will take off. I'm just going to look at the first few years. That's going to be pretty linear to start. Could probably check 5. 5 is going to be 1403. Yeah, pretty accurate. Remember, at some point that will really take off. So going to look linear here to start. Probably could have done a wider range on my years. When does the account reach $2,000? Well, again, you can trial and error this thing. If you go to 10 years, you get 1967. You plug in 11 years, you get 2,105. So somewhere between year 10 and 11. Give an example of domain for which the average rate is a good measure. So where is a good indication of an average here? This is pretty flat, somewhere in the middle here, 4 to 8 maybe, 4 to 7. Domain is our X values, so I think 4 to 8 is a pretty good indication. Give an example of a bad average. Well, if you do the whole thing, it would not be a very good average because it really takes off. It's really flat here, so to me, 0 to 15 is a bad example. Explain why P equals 3n plus 2 defines this function. Well, it is 3 people per table, and then it's 2 on the ends. 2 people will sit on the ends. How many tables are needed for 47 people? So you can just trial and error. If you try 10, 3 times 10 plus 2 is 32. That ain't enough. Try 20. 3 times 20 plus 2 is 62. Actually, 15. Plug in 15 there, you get 47. And 99 people come. How many tables do you need? So now this is 99. Just solve that. Subtract 2. Divide by 3. 97 divided by 3, 32 something. So I'm gonna need 33 tables to fit everybody. Write the inverse. All right, so remember the inverse, I need to do the opposite. I gotta solve for n, so I gotta subtract 2. And I have to divide by 3. Explain what the inverse tells us. If you know P, that's the number of people, you can determine tables needed. And that is it. Hopefully that went well for you.